We recently reported that BMW has submitted a patent for an odd aero system design to provide downforce in corners. Now, the firm has submitted another patent targeted at the M1000RR and S1000RR that accomplishes the same goal but does it in a totally different way. The patent suggests converting conventional static winglets, which have been showing up more frequently on superbikes lately, into active winglets. The theory behind it is that when the motorbike is traveling straight, static components stabilize it and increase grip, but during a bend, the airflow changes unexpectedly. And that can lead to issues. Therefore, in order to increase the motorcycle's total downforce without compromising stability on the track, BMW engineers sought to decrease airflow even when leaning and directing it in the desired direction. According to the patent, BMW engineered the system such that, regardless of the motorcycle's tilt, the winglets would always be parallel to the road surface. This generates useful downforce in the appropriate direction. Then that's very awesome. But not for regular motorists. Indeed, the M1000RR and S1000R may soon get this technology, but much like the intriguing elements that Aprilia, Ducati, or Honda brought to the MotoGP pros are now prohibited from using MotoGP active aerodynamics. Since the patent only specifies that the winglets are articulated with actuators, it is unknown how BMW's technology operates. The sensor features a clean and conventional setup that includes a tiny bar sensor in the system along with a modern superbike with stability control, drift mode, and a separate bar motor. And the latest information in terms of engines, BMW Motorrad is the latest participant to join the league of manufacturers that have patented supercharged engines. New patent images that have surfaced online show a BMW S1000RR-based motorcycle with an electric supercharger. So what is this BMW S1000RR-based motorbike like? To understand, let's first look at a forced induction machine. A supercharger is essentially an air compressor that increases the pressure or density of the air supplied to an internal combustion engine. This allows more oxygen to enter the engine, allowing more fuel to be burned, thus resulting in increased output. In contrast, a turbocharger increases efficiency and power output by forcing pressurized air into the combustion chamber. This allows the compressor to force more air, which directly causes more fuel to enter the combustion chamber than atmospheric pressure. The supercharged BMW S1000RR is the future. Increasingly stringent emission norms mean that manufacturers have to be vigilant, with their research and development teams busy developing more efficient and less polluting engines. In fact, we wouldn't be surprised to see all manufacturers switching to forced induction engines. First to expensive flagship phones and then to more affordable models. However, don't expect a supercharged BMW S1000RR to be launched anytime soon.